All right, in this video we're going to look at quadratic equations. So a quadratic equation has the format shown here, ax squared plus bx plus c equals 0, where the a, b, and c are real numbers. And we don't want the a to be 0 because we'd like to have the x squared term there. That's what makes this equation quadratic. This is also called a second degree equation, and that's because the highest power on x is a 2. And when we solve this equation, the solutions are the x-intercepts of the graph. We've spent a lot of time looking at the graphs of functions of this type. So just to connect the function with the equation, if I were to graph y equals the left-hand side here, I'd get my parabola. And so I'm just going to draw some generic parabola, okay? The place where my parabola touches the x-axis, that's where the x-intercepts are. And those points, the x values of these points, are the solutions to this equation. So we've done a lot of solving work centered around the parabola. So it is fairly important to kind of separate for yourself what each calculation is finding concerning the parabola. Okay, so in all the calculations we're going to practice in this section are the x-intercepts. Okay, so when we go to solve, there's actually several solving methods that we can use. We're going to look at 4 methods. We can solve by factoring. We can solve with the square root method. We can solve with the quadratic formula, or with completing the square. Each of these has their strengths. So we should take a minute just to talk about when it's maybe best to use one method above the other. I usually list factoring first because it's the fastest, right? Especially because usually in an algebra class you've taken some time either this semester or in previous classes to practice factoring. So we look at something and we see the factoring. Maybe that's true for you, maybe it's not. But if you have a good amount of factoring skills, factoring is usually the fastest method. If it's factorable. Some equations are and some aren't. Okay, the second method, the square root method, is going to be helpful if all the variables are sort of bound up inside of a square. So that could mean maybe we only have an x squared, we don't have an x term, or maybe we have a parentheses squared. Those are the best times when the square root method would be the most useful. The last two here will always work. The quadratic formula is a formula that will always take a quadratic equation in the format we've shown right here and solve for the x. So that's a good fallback because it always works. Completing the square is another method that always works. So we'll take the time to show you that method, and you can kind of see what you think of it. There are some people that really like completing the square, and then they want to use it all the time. So we'll give you a look at what that looks like. I'm not going to talk about the discriminant today. The discriminant is part of the quadratic formula. So if you want to read about what the discriminant can do, where it is in the quadratic formula, and what it can be used for, it's on page 181. Okay, so I'm going to kind of go down the list and show you, kind of demonstrate these different solving strategies today. The first one being factoring. So the basic process for solving by factoring, we need to get 0 on one side of the equation. So we're going to move everything together on one side. Then we're going to do our factoring. And then we're going to do what's called, or apply what's called the zero factor property. This basically says that if I have 2 or more things that multiply together to be 0, think about 2 parentheses that multiply to be 0, then one or both of those parentheses must have been 0 in the first place. That's the only way we can multiply and get a result that's 0. And so we're going to use that and set each part equal to 0. Let's try that out on this. I think this is number 4 from your book. Okay, everything's already to one side. We have 0 on this right-hand side, so we don't have to worry about the first step. Then we can do our factoring. I'm going to be using trial and error today just because I feel like that's the fastest, but any of the factoring strategies we've talked about you can use, or any that you have that you're accustomed to using would work well. So I know that x times x will make x squared. I need two numbers that multiply to be 8 and add to be 6. I'm thinking 4 times 2. Okay, and then I want it to add up to be a positive 6. So both of these would be positive. Then the zero factor property says either one of these parentheses or both of them must have been 0 in order to multiply and get 0 as a result. So to get all the possible solutions, we're going to set each part equal to 0 and use that to solve for x. So we end up with two solutions, -2 and -4. Now I'm feeling fancy tonight, so I'm going to list them in the squiggle brackets. You don't have to do that if you don't want to. Okay, just to give you a visual mental picture. Here's -2 and -4. This parabola right here, if we were to graph it, would touch the x-axis at both -2 and -4. Okay, now I didn't graph it precisely, but I'm just trying to give you a mental image of what that would look like. Okay, let's try another one. We have 4x squared minus 12x equals -9. This process relies on 0 being on one side. So my first step would be to add this 9 over to the left-hand side. Then I'm ready to do my factoring. This is one that requires trying some things out. Usually if I see a perfect square in the front and a perfect square in the back, I'm inclined to think that I'm going to be dividing these up equally. So I'm going to try that out. So 2x and 2x. You could have tried 4x and 1x, right? Whatever you think might work the best. 9, 3 times 3 is 9. Now keep in mind that there's a number in the front here, so 3 times 3 is 9, but obviously 3 and 3 are not going to add up on their own to 12, but these 2's in the front are going to play a part. Right, so if I FOIL this out, on the outside, I'm going to have a 6x, and on the inside, I'm going to have a 6x. And I would like them to add up to the middle, which is -12x. So I need them both to be negative. Okay, so sometimes this happens. This is a perfect square trinomial where I get two of the same parentheses here. Since they're both the same, I really only have to set one of them equal to 0 because they're going to give me the same answer. And then I'm going to solve for x. I'm going to add my 3 over and then divide by 2. So I just get one answer this time, 3/2. Or you could change it to 1.5 if you like the decimal form better. in terms of the mental picture of the parabola, oops, it's on this side, isn't it? This one is going to touch at, we said 3/2 is about 1.5. Okay, and so this parabola just touches the x-axis at one single point, right at the vertex. And that's what's happening when we just get one answer. Okay, so that's the factoring method. Let's move on to the next one, which is the square root method. So the steps for accomplishing the square root method, we're going to isolate the squared term. And for these two examples here, that is the parentheses squared. If there aren't any parentheses, maybe you just have an x squared and you want to isolate that or get it by itself. And then, because we want to remove the square or the exponent, we're going to apply a square root to both sides. Right? A square and a square root are opposite operations, so they cancel each other out. Anytime there's not a square root, but we put in the square root, we need to include a plus or minus so that we get all the possible solutions. Okay, so let's try that out on this one. We have x minus 4 in parentheses squared minus 25 equals 0. The first task is to get the parentheses squared by itself. So we'll add the 25 over to the other side. And then to remove this square, we're going to apply a square root to both sides. Each number has both a positive and a negative square root. So that's why we need to put in the plus or minus. I usually put that on the right hand side. I think that's the easiest place to work with it. On the left hand side, the square and the square root are going to cancel each other out. So I just get what's underneath. The whole radical symbol goes away. On the right hand side, we know the square root of 25 is 5. Okay, you have a couple of options of how you want to work this out from here. I like to add the 4 over and put it in the front and then calculate my two possible answers. If you would rather, you could split this up right now into two possibilities, right? X minus 4 equals positive 5 and x minus 4 equals negative 5 and work them out individually. That's another option. I like to do it this way and keep it together. So I'm going to show you that today, that either option is equally valid. Okay, and then here is where I like to write down my two options. So I have, I'll just do it like this. So I have 4 plus 5. And that part I kind of usually do in my head. That would be 9. And then I have 4 minus 5. And that would be negative 1. So if you're feeling fancy, you can put it in the squiggle brackets. I'll even put it from smallest to largest today. So we get two possible answers. Okay, and we could do the same parabola picture. I won't draw that this time, but these, remember, are the x-intercepts. All right, let's try a second one. Same process. You remember what to do first? We're going to subtract 16 on both sides. And then we want to take away the square. So we're going to take the square root of both sides. Don't forget the plus or minus. This problem is a little bit different. The square and the square root are going to cancel each other out on the left-hand side. What's going on the right-hand side here? What is the square root of negative 16? It is a complex number. So the square root of 16 would be 4, but because it's negative, we're going to have the I. Right? And we looked at that in a previous video. So if you need to go back and see that again, there's a video for that. Okay, and then our goal, remember, is to get x by itself. So at that point, we're going to subtract the 3 over to the other side. So we get negative 3 plus or minus 4i. And I'm happy for you to leave the answer just like that. If you want to list it out separately, online, MyMathLab is going to ask for it written out separately. This is actually two complex numbers, negative 3 plus 4i and negative 3 minus 4i. The complex number solutions always come in these conjugate pairs, right? One with a plus and one with a minus. So what does that mean in terms of the parabola picture? All right. I'm going to draw a very primitive sketch here, okay? But this parabola, because these are complex numbers, we don't have any complex numbers on the x-axis, right? So this parabola does not touch the x-axis. So if we get a complex number solution, that means that there are no x-intercepts for this graph, and that's okay. Okay, so that's the square root method. Let's move on to the third one. So the third one is the quadratic formula. This is the only formula that I usually have you guys memorize. I really just feel like if you're an algebra student, this is the one algebra thing that you want to walk away with. Okay, so there are lots of YouTube videos out there that give you a song for the quadratic formula if you're looking for a mnemonic of some kind to help you remember it. All right, but here it is, right? So we're solving for x. We're using a formula that looks like this. ax squared plus bx plus c equals 0. That's where we're getting the a's, b's, and c's. We are still solving for x. So we have the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we made reference earlier to the discriminant. This is the part right under the square root, the b squared minus 4ac. The value of that expression can tell you what kind of answers you're going to get. So you're welcome to use that if you want. All right, so let's try it out on this equation. We have x squared minus 4x plus 2. What are the a, b, and c for this example? Yeah, there's an implied 1 here in front of the x squared, so a is 1. The negatives are always attached to the number behind them, so b is negative 4, and c is 2. We're going to plug these into the formula. So we have the opposite of b, the opposite of negative 4. I always write this out to be obvious to everyone, but you can definitely do that part in your head, taking the opposite, that is. Then we have plus or minus the square root of b squared. I highly recommend that you write the b in parentheses here so that when you square it, you remember to also square the negative. That's a very big point to make. It's a very common error. I've graded lots of tests. It's a very common error. Okay, so negative 4 squared minus 4 times a, which is 1, times c, which is 2, all over 2a. I will say that when we solve with the quadratic formula, usually if we've remembered the formula correctly, this part looks great. it's from here to the final answer that the mistake is made. So I want to encourage you to write out as many steps as you need to and be very careful with your simple math as you're going along from line to line. Okay, so this becomes a positive 4 plus or minus, this is positive 16 minus 8 all over 2. Okay, and we want to handle the square root first. So this will be written too big here. 4 plus or minus the square root of 8 over 2. Okay, now it would be wise, if we can, to pull anything outside of the square root that will come out. So if you think of 8, right? Anything that's a perfect square can come to the outside. That's something that we learn about a lot in intermediate algebra. So let me give you a refresh real quick. So 8 is 4 times 2. 4 is a perfect square. I'm allowed to break up a square root over multiplication. So when I simplify the square root of 8, a 2 comes out because the square root of 4 is 2, and I have 1 2 left in there. Okay, so this becomes 4 plus or minus 2 square root of 2 over 2. And then each of these parts here that are either added or subtracted together are both divided by 2. So if it's helpful, you might want to write each part over that 2 in the denominator so that you don't forget to divide it into both parts. So 4 divided by 2, I know that's 2, and then 2 divided by 2, we could make that a 1, or we could sort of take that away. So our final answer here would be 2 plus or minus the square root of 2. Okay, so trick question. Could we have divided this 2 straight into the 8? Absolutely not, right? The 8 is under the square root. This 2 in the denominator is not under the square root. So those are different types of numbers. Same thing would apply here, right? Notice we divided this 2 in the denominator with the 2 on the outside. It would not be appropriate to divide it with anything underneath the square root because they are different types of numbers. Okay, we're going to leave our answer like this. You could write it as 2 separate numbers if you want. This is the exact format to leave it with the square root. So usually that's what we do. You could approximate this with a decimal if you want. This is the type of answer I will be looking for. So you can leave your answer just like that. All right, let's try one more. Okay, so A is 1, B is -2, C is 5. We're going to put that into our formula. So the opposite of -2 plus or minus the square root of -2 squared minus 4 times 1 times 5 all over 2 times 1. If we simplify that, that's going to be 2 plus or minus the square root of 4 minus 20 over 2. 4 minus 20, that's -16 underneath the square root. Can you foresee where we're going with that? What is the square root of -16? 4i. Okay, and both parts are going to get divided by that 2 in the denominator. So our final answer would be x equals 1. plus or minus 2i. You're welcome to leave your answer like that, or you could write out the conjugate pair that we talked about earlier. All right, so that's the quadratic formula. Let me take a minute to show you the last method. It's called completing the square. So the goal for the completing the square method is to create a perfect square. A perfect square is going to look like parentheses squared. So basically we're going to take this format of the equation and we're going to rewrite it in a factored format where we have a parentheses squared. And that's sort of what the completing the square, that's the main gist of it, right? And then the last step, once we have it all factored, we can apply the square root method. Okay, so here are some steps you can follow. This looks daunting at first, but after you put it into practice, I promise you it's really not as scary as it looks. Okay, so the first step is that if the first number there, the a, if that's not 1, then we want to divide both sides of the equation by a. Then we're going to move the constant term. The constant term is just the regular number part, the c. We're going to move that over to the right-hand side. Once we've done that, we've gotten the a out of the way and we've moved the c out of the way, we have something that looks like x squared plus a number times x. Okay, and that's what we're going to turn into the parentheses squared, or the perfect square. So once we have x squared plus something like bx, we're going to add an amount or a number to both sides of the equation. We're going to talk about how to choose that number in just a second. Okay, and that sort of relates to what this parentheses says here. We can use the square of half of the x coefficient. So I'll explain that in a second. Once we've done that, then we're going to factor the left-hand side into our perfect square. Right, so we should have two equal parentheses that are the same, and then we're going to write it, because they're the same, we can write it as a perfect square. And like we said earlier, the last step is to use the square root method. Okay, so let me demonstrate that to you, because it's a lot easier to watch than it is to explain it in words sometimes. So here's the equation that we have, 3x squared minus 6x minus 12 equals 0. The first step is to divide everything by a, so I'm going to divide all of this by 3 on both sides. So then I'll have x squared minus 2x minus 4 equals 0. The second step is to move the constant term over to the right-hand side. So I'm going to add the 4 over to the right-hand side. Okay, and then as you're writing the next line, you're going to want to leave a space because we're going to add a number to both sides. Now, I don't have the best memory in the world, so to help me remember to add the number to both sides, I usually draw a little blank on both sides. I'm usually really focused on the left side, and so I'm good about adding the number there, but sometimes I forget that I have to also add it to the right-hand side. Okay, so now we can talk about how to reason out which number we want to add. You can reason this out in a couple of different ways. You could think ahead to the next step. In the next step, we're going to factor what we have on the left-hand side here into two equal parentheses. And you could use that factoring to help you decide what number must go here to make the parentheses the same. Okay, so let's think through that for this example. I'm going to factor this, so I must have an x and an x. And then I need two numbers in the back that are equal that add up to -2. What two equal numbers add up to be -2? It must be -1 and -1. That's my only option. They have to be the same, okay? And they're going to add up to this middle number. All right, so now that we have that lined up, then the FOIL part, right? We've FOILed everything except the last times the last. So -1 times -1 would be +1, and that's the magic number that we want to put in this blank. So you could use the factoring to figure out that number. Okay, or there's a shortcut, and I guess that's what this was referring to here in the parentheses. So the shortcut is you can take b, the number in front of the x, divide it by 2, and square it. Okay, so let's work that out for this problem. In this problem, the b is -2. So -2, we're going to divide it by 2, which is pretty much what we did when we came up with these two -1s, okay? And then we're going to square it, which is what we did when we FOILed the last times the last to get this. So it's really not any different, it's just written in a different way. So -2 divided by 2 would be -1 squared, which would be 1. And that's the number that we added to both sides. Okay, that step's really crucial, so if you didn't understand it, go back and listen to it one more time. That really, the completing the square hinges on you finding the correct number to fill into that blank. Okay, and then 4 plus 1, we know that's 5. Then the next step is to write this as a perfect square. This is x minus 1 squared because I have 2 copies. And then the last step is to use the square root method. So now this is, it wasn't set up for the square root method when we started, but the completing the square process is the setup so that we're able to now use the square root method. So to remove the square, we're going to take the square root of both sides. Don't forget the plus or minus. The square and the square root are going to cancel each other out. And our goal here is to solve for x. So we're going to add this 1 over to the right-hand side. So we end up with 1 plus or minus the square root of 5. Same thing would be true for this question. That's the exact form, and we're going to leave our answer just like that. Unless you want to separate it into the two numbers. So that's 1 plus the square root of 5 and 1 minus the square root of 5. You could write it like that as well. Okay, let's try one more before I leave you. If you want, you could pause the video and try this out on your own. Let's see if you get it worked out the same way I do. Okay, we're going to go through those same steps. The first step was to divide by a, but a here is 1. So I don't actually have to do that first step. It's already done for me. The second step was to move the constant term over to the right-hand side. Remember we said we're going to leave a space, because once we've done that, the next step is to add a number to both sides. Okay, now same thing applies here. You can reason out the number you want to add here in 2 different ways. I like to use the factoring because that's more intuitive for me, but if you didn't want to use the factoring, you could use the shortcut. Okay, if we were to factor this, 2 numbers in the back here that add up to be -4, 2 equal numbers, must be -2 and -2. And then when I do my foiling, the last times the last, -2 times -2 tells me I need to add a 4. here on both sides. Okay, if you want to use the shortcut, up here, we have -4 as our b. We want to divide it by 2 and then square it. So when I divide it by 2, that's what I'm going to see in my factoring, at -2. And then I'm going to square it to get the number I need to add to both sides. From here, we're going to write it as a square, and then use the square root method. The square and the square root are going to cancel each other out, and we're going to add 2 to both sides to get x by itself. All right, I hope that's given you a pretty good look at how to solve a quadratic equation. We've looked at 4 different solving strategies today, so I want you to take some time, look through the book if you need to, find some examples that you can use to practice all 4 of these methods so that you're comfortable with them and you can use them at your will, right? Whichever one you need at the moment. All right, best of luck to you.